Hi class, I'm Professor Steele. Today we are going to look at another trigonometric identity to prove. You'll notice this one looks very different than the last one we looked at. Again, recall, with identities we work with one side at a time. So obviously we're going to pick the left-hand side because it has the most terms and the most complicated form. So let me just rewrite that left side before we dive into this. You'll notice that the second term has a cosine x times a cosine negative x. So here's where we use our even/odd identity. The cosine of a negative x is equivalent to cosine of the positive x. So we can replace this piece of the second term with cosine x. So we have sine squared x minus cosine x times cosine x times sine squared x. Well, that looks a little better. Let's clean up the cosines, combining them to make cosine squared x times sine squared x. Now here's a situation that might arise in another problem that you might see. At this point, what do you think we should do? Or what do you recognize? If you have said we have a sine squared x in both terms, then the next thought process is we should be able to factor it out. So if we factor out a sine squared x, what are we left with? If I divide out my first term, sine squared x, by sine squared x, I'm left with 1. If I divide my second term by sine squared x, I'm left with cosine squared x. In other words, as a double check, sine squared x times my first term should give me this term. Sine squared x times the second term in the parentheses should give me this term. We're almost there. Recall our Pythagorean identity. Sine squared x plus cosine squared x equals 1. That means that 1 minus cosine squared x can be replaced by sine squared x. So we have sine squared x times sine squared x, which gives us sine to the fourth x, which is our right-hand side. Therefore, QED. Proven. Thanks again for watching. Please like and subscribe to EdVantage. We'll see you next time.